So now we know how to determine the molar mass for atoms in an element by looking at the periodic table. And the bottom line is the molar mass is going to be our conversion factor between mass and mole. Now, unlike Avogadro's number, 6.022 times 10 to the 23, which is always the same, molar mass changes. It depends on composition. So if we look at 1 mole of iron atoms, they weigh 55.85 grams. And this is about twice the amount of mass in a mole of sodium atoms. And that's because sodium only has 11 protons and 11 or so neutrons. Iron, on the other hand, has 26 protons and about the same number of neutrons. So it's going to have a different mass even though the number of atoms are exactly the same. So now we know that molar mass is going to be our conversion between mass and moles. Let's take a look at a practice problem. Let's calculate the moles of carbon in 0.0265 grams of pencil lead. And remember, pencil lead is graphite, which is one of the naturally occurring forms of elemental carbon. So let's start out with what we're given, 0.265 grams of carbon, or the lead in a pencil, and we want moles. Well, we know the conversion factor between mass and moles is molar mass, and we're trying to figure out the molar mass of an element. We look on the periodic table. Here's carbon right here, 12.01 grams. And we know it's grams because these are the units we use when we're talking about a mole. So let's do our unit check. We have grams of carbon, moles of carbon, moles of carbon. 2 of each. We're ready to do our railroad math. We start out with our given, 0.265 grams of carbon. And since we have grams of carbon here, we need grams of carbon down here. So 12.01 grams of carbon. And the other half of our conversion factor goes on top. Okay, our grams of carbon cancel out. The units I'm left with are moles of carbon. And then when I divide 0.265 by 12.01, my calculator tells me 0.022064945. Okay, so let's look at sig figs. I'm going to use my given value as my significant figure indicator. I have 3 sig figs, so my answer can have 1, 2, 3 sig figs. There's my last allowable sig fig. I look to the right. That's greater than 5. So 0.0221 moles of carbon. Now, if your calculator is giving you your answer in scientific notation, this is what it would be. Okay, so we want to make sure that we have moles of carbon written down. That's what we want. And then we want to say, look at our answer and ask ourselves, does it make sense? Well, I have 0.265 grams, and that is about 2 orders of magnitude less than the 12 grams that makes up a mole. So I should be less than a mole. I definitely am less than a mole by about 2 orders of magnitude, and that's correct. 2.21 times 10 to the minus 2 moles of carbon. My answer makes sense. Okay, so let's look at this next practice problem. How many moles of sulfur atoms are in 57.8 grams of sulfur? Okay, so pause the slide and see if you can figure it out. And when you get an answer, restart the lecture and we'll go over it. Okay, the first thing we do is write out our given and our want. And let's go ahead and write out that it's grams of sulfur. We're given grams, we want moles, and our conversion between mass and moles is molar mass. So to find the molar mass of sulfur, we look on the periodic table, and it's 32.07. So we'll write that down on our conversion. Units of grams, because we're looking at a mole. We have 2 grams, 2 moles. We're ready to do our railroad math. So here's our given. It always goes in our first compartment. We have grams of sulfur, so grams of sulfur must go at the bottom. 32.07 grams of sulfur is equal to 1 mole of sulfur. And our grams of sulfur cancel out. And when I multiply 57.8 by 1 and divide by 32.07, I get 1.802307452 moles of sulfur. Okay, now let's look at my sig figs. 3 sig figs am I given? 1, 2, 3. There's my last level sig fig. I look to the right, that's less than 5. So 1.80 moles of sulfur is my final answer. Now let's see, does this make sense? This is about 2, and this is almost twice the amount of the mass of 1 mole. So yes, our answer makes sense.